Hi guys, right, so today day 2 of these videos here based on the homework that I set for you for today. A couple of you haven't submitted it or have submitted it incorrectly, so Emma, will you make sure that you, rather than email it, submit it via the assignment section. Miwash, I haven't got anything from you yet, need to get that. There's one or two other years there that are the same. Adam, I still have to get Wednesday's homework off you. And again, 1 page for today, I think, is all that was submitted. So we need to get you up to speed. All right. So again, for anyone that's tuning in, I don't know how the last video has over about 580 likes or views, I think, or something. I don't know who's sharing it or what you're doing, guys, but this is meant to be just for our class here, all right, or anyone that I suppose I get a bit of use out of it. 580 views from 10 students. I don't know what you're doing, all right. But for anyone out there that's looking, Text and Text 2, alright, the higher level junior cert edition book, and again we're on trigonometry. So excuse the work clothes, just out doing a few jobs around the house, keeping busy, but here we go anyways, alright. So what have we got? We basically have a room here and all these measurements are in meters, alright, so 4 meters by 2.75 meters is the room, and we are asked, can we rotate that desk so that it'll fit along the horizontal wall? Alright, now you can see that the total width of the wall is 2.75 meters, the total length of the desk is 2.3, so the desk would fit up there, but the question is, can we rotate it? Alright, without twisting it or doing anything, just can we rotate it? So basically we want to look at if this diagonal length, alright, if that diagonal length is less than the width of the room, then yes, we can rotate it. If we can't rotate it, then that means that measurement is longer, so we're not going to be able to turn. So what have we got? We've got a right angle triangle. We know 2 sides. How do we find the third side? Pythagoras. Okay, so here's my right angle triangle. So the length of the hypotenuse is what we're trying to find, so we're going to call that x. So hypotenuse to be squared is equal to the sum of the other 2 sides to be squared. Alright, 1.6 meters to be squared, 2.3 to be squared. So x squared here is equal to the sum of those 2 sides to be squared, and get the calculator. Alright, so 1.6 to be squared plus the 2.3 squared, and I'm going to get 7.85 meters. 85, yeah. Alright, get the square root of that. So square root of your 7.85. And that's going to give us an answer of 2.8 meters. Alright, now if we look at that measurement, the 2.8, you can see there that that is wider than 2.75. So no, the desk will not turn. Alright, now I just looked at 1 or 2 of your hand ups there, and you told me yes, John, you got the right answer and said that no, you couldn't turn the desk because it was too big, but you didn't actually do the calculations to prove that the diagonal, basically, if this is my hinge point, if I hinge that desk around, well then the 2.75, 2.8 wouldn't turn in the 2.75. Alright, so you have to prove your work. Alright, now it's 13. So here we have question 14. Alright, it's to do with, a lot of us now are at home on computers and all tablets and all the rest of it, and it's to do with occupational height for viewing a screen. So you've got somebody here, they're viewing it, alright, and there's a computer screen. The only measurement we were told is that the diagonal, basically the hypotenuse of a right angle triangle, that length is 55 centimeters. We're told that the correct angle of depression when you should be looking at should be 15 degrees. And 2 questions is basically how the height here that I've labelled in x, basically how high should your eye line be from the centre of the computer screen there. Now, maybe not drawn completely to scale, that line probably should be going closer where the x is into the centre, but that's the question. Find how high above the centre of the screen should your eyes be? Part 2 is find how far back should your eyes be. Alright, so we've got a right angle triangle. We're going to be working with trigonometry. Okay, so first of all, to find x, right, again we'll label our sides. Now I don't think blue and black show up so well on this, but anyways. Right, 90-degree sine, so this is our hypotenuse, label them in H. This is the angle in question, so this is the side opposite, this is O, and then this is our adjacent. Alright, so dealing with x first, we're going to find x first. O and H we know is sine. So sine of our angle, which is 15 degrees, alright, so sine 15 degrees will be equal to, so silly, old all over H, O, H. So O is our x, silly, over Harry, which is 55. X is tied up as part of the fraction. We want to isolate, so we're going to multiply by the denominator, both sides, so 55 sine of 15 degrees will be equal to x. So 55 by the sine 15. Alright, and we're getting 14.24. So 14.24 centimeters is equal to x. And we're asked to give that to correct one decimal place, so it'll be 14.2. Alright, now we want to find how far back from the screen we should be. Well, nothing has changed in terms of our labeling of our three sides. This is still our hypotenuse, this is the angle that we're given, so this is still our opposite side, and this is our adjacent side. So now we want to work with what ratio we're trying to find. We're trying to find A, so A has to be part of your trig ratio. Alright, you had your hypotenuse from the start, you found O, so you could really use anything. So if we go silly, old Harry caught a herring, so you could use cause, or you go tan trolling off America. So whichever you want. When you want to go, we'll go maybe with cause. So I'm going to say cause of the angle of 15 degrees is equal to caught a, which is y, herring, which is your 55. If you went the other way, you'd have an extra step, which your tan. So again, multiply both sides by 55, and the cos of 15 will be equal to y. So 55 and that's telling us that it is greater to 1, so 53.1. Alright, so again, right angle triangles, dealing with your trigonometry for question 14, right angle triangle, simply Pythagoras for question 13, and you simply had to then just deduce for 13 that if the diagonal there, the line in red there, if that's too, if it's bigger than the width of the room, then well, you obviously can't turn it. Now yeah, you could twist it around and do all that and get it, but right, so here we are, actually question 15. We're on to there. Alright, so basically what we have is we have two boats, part at P and one part at R. Alright, and we have a person here, I think she's standing at B, Marguerite. Alright, and she walks from B to A and she figures out that distance there is 54 meters. Alright, and she also is able to work out the two angles there in the question, this angle here being 43 degrees, this one here being 47 degrees, and we're then asked to basically find a couple of bits of information out on this. Alright, this is always a nice question. I do like this one in that you have a bit of thinking to do. There's a couple of different triangles going on, you kind of figure out what you want to do, what you want to achieve from it. Right, our first task though is going to be find W. So basically find that length W, alright? What we're going to assume is both sides of the river, I think this is a canal or something, that the two of them are parallel, alright? So basically what we have in here is two parallel lines, alright? And it's creating a 90-degree angle here, 90-degree angle here. So you've got two right angle triangles, so you're able to go ahead and use your trigonometry to solve. Alright, so first of all, draw it out. Okay, so do you remember what I was saying to you? Make sure you draw the solution, don't just go and do your calculations, draw it out. Alright, so I want to label now the different parts in terms of your hypotenuse, opposite side and adjacent side. Okay, so this is our 90-degree angle, so then this is our hypotenuse, so this is H. Alright, this is the angle in question, so this is the side O, our opposite. And then obviously then the third one is our adjacent. We want to find W, alright, so O and A. Alright, so we're looking at what trig values can we use to figure out our O and our A. Alright, so a silly old Harry, no. Caught a herring, no. Trawling off America, yes. So it's tan, alright, so it's tan of the angle. And the angle is 43 degrees. Tan of the angle is equal to trawling off, which is your W, leave it as W, all over A, which is 54. Alright, we want to find what W is, so multiply both sides of the denominator to get W on its own. Basically multiplying and dividing by the same number cancel each other out. If you multiply 2 by 2 and divide it by 2, you're still going to get 2. Alright, so multiplying and dividing by the same number cancel each other out. Alright, so 54 by both sides. Into our calculator, 54 multiplied by the tan of 43 is and I'm guessing the nearest meter, nearest one decimal place. Alright, so 50.4 is equal to W. Alright, so I'm going to remove W, put in 50.4, not point W. Alright, now moving on, so that's that part done. Now we want to find the length BC. Alright, so where is BC? Here to here is BC. What do we know about this triangle? We don't know any of the lengths. Or do we? Stop, pause, think about it. We have figured out A to P. Alright? We're presuming that the two sides of the canal are parallel. So this gap here and this gap here is the same. So we're going to presume this is also 50.4. Alright? Now we're trying to find this one, so we'll label this in X. That's what we're trying to find. Alright? So here we'll do exact same thing again. Get your red wire out, or pencil or whatever, label your parts. 90-degree angle, side opposite is H. This is the angle in question, so this is your side O, and this is obviously A. Now we have O, we want to find A, exact same as what we had up here, O and A, so again it's tan again. Alright, so tan of the angle, and this time the angle is 47. So tan of 47 degrees is equal to drawing off all over A, O all over A, so 50.4 all over A, which we're calling is X. Now, if you just look at the difference in top and the bottom. In this fraction, the unknown, the one we're trying to find, is the numerator. Down here, X, the unknown, is in the denominator. And we'll see when your unknown is in the denominator, you do one extra step compared to this example. So just have a look and we'll learn. So again, I want to isolate X, so I'm going to multiply both sides by the denominator. So X and now that was all I done up here, and I got straight into my answer. But this time I have to do an extra step because now my unknown, or what I'm trying to find, is part of the multiplication. So divide by the other side of the multiplication, so basically the number that we know, because remember this is just a number. So dividing both sides by the tan of 47, I'm going to end up getting x is equal to 50.4 divided by your tan of 47 degrees. And x then is equal to, and remember, to the closest one decimal place, so it's 46.99, so rounding that up, so you're going to end up getting 47 meters, right? Yeah, meters. Alright, so 47 meters. And remember, this measurement up here was also in meters. Okay, so we've now found from B to C is 47 meters. Alright, so that's that part done. And the last thing is find the distance from P to R. So P to R. Alright, now you could go off and you could go calculating and doing more trigonometry and figuring out this length and that length and then Pythagoras or whatever if you wanted. Or if you look at, well, from A to B and B to C is the same as from P to R. So we're going to add your 54 and the value we got from A here is this. So the distance from P to R is equal to, what we have, 54 plus R 47. Alright, so 50 and 40 is 90 and 11 is 101 meters. Alright, and that's 3 parts done. And just take a look at how we would actually set up and lay it up. Right, part 1. Alright, but I have my diagram. Now I know that's just a copy for the book for the video purposes here. But again, if I was solving this in class, I would still draw it. Alright, drawing it is so valuable to working out these questions. Alright, second part here. Alright, again, just different triangle, exact same procedure, and then just the overall length adding my 2 meters. Alright, thanks. Alright, so this is question 17. Alright, so I skipped on from question 16. Alright, basically what we have, we've the side of the cliff face. I'm just going over 16 for you there. So you have side of a cliff face there, and you've got 2 triangles, one which is a right angle triangle, alright, and inside of that there is point Y to, so YZP is the first right angle triangle, XZP is a second right angle triangle, and you have to work out the length of PZ, basically the height of the cliff. So you're able to use the fact that you have right angle triangles there. So it's the exact same kind of as what we've done, so I'm not really going to go through it. If you want, drop me a question and I'll give you a hand on it, but I don't think there's any need. Alright, we're on to 17 here, so which is to do with Harry and his roof. He's re-roofing his shed. Alright, so here's the roof here, and basically he's going to cover the roof in felt first of all, and he needs to have adhesive here for the felt as well, and we're told that for €18 it will cover enough for 6 meters squared. So what we want to basically do is work out the area of the roof, and then we're basically at the end working out the overall cost. This cost of these rolls are actually, what are the rolls? €40 a piece. Alright, so the rolls are €40 and the adhesive is €18 for 6 meters squared. So step 1, we're going to find the area of this roof. What type of shape is it? It is a rectangle, right? Do we know the length? Yes, it's 4 meters wide. Do we know, or long should I say, do we know the width? No, we're told the width of the wall, right? But that is a horizontal measurement. That is 2 meters there. It's not this diagonal, alright? So basically what we have is, we've got a triangle, alright? So can we get the hypotenuse of that triangle? So imagine we're taking a horizontal line, right, a plumb line with your spirit level, alright, for that dotted line there. That width is 2 meters. If you look at the back height of the wall is 3, the front height of it is 2. So then this height here is 1 meter. So 1 meter here, 2 meter here, triangle. We need to find the length of the hypotenuse. So draw out, a right angle triangle. This is the top bit of this roof. Alright, the height of it is 1 meter, the width of it is 2 meters, and we basically want to find x. Alright, how do we find the third angle in a right angle triangle? Pythagoras. Alright, so it is x squared is equal to 1 to be squared plus 2 to be squared. So x squared will equal 1 squared is 1, 2 squared is 4, 4 and 1 is 5. So x here is equal to the square root of 5. Alright, I'm just going to leave it as the square root of 5 rather than working it out in decimal form for when I'm working out the area. Alright, for the time being. So I now have this diagonal, which is the square root of 5. I know that the length of the roof is 4 meters, so can I work out the area? Yes, I have a rectangle, 4 meters by the square root of 5. Square root of 5 by 4 will give you the area. So the area of that roof is equal to 4 times the square root of 5, and that's the key figure that I want to work out. So 4 by the square root of 5 is 8.944. So 8.944 meters squared is equal to the area. Alright, so if the area of this roof is 8.944 meters, one tin will only cover 6 meters squared. So I need 2 tins. So first of all, working out this is, we have to work out the cost to the materials for the roof. So it's going to be my 18 euros by 2. Alright, because we can't buy a bit of a tin, you have to buy a full tin. So 6 and 6 is 12, so we're going to have a bit left over, but 18 euros per tin is going to give you 36 euros. Alright, then we want to look at, well, we've got the roll of felt here that's going to go over the roof, and it is 1 meter by 5 meters. Alright, so if we think we're going to, you could think practically of this, or you could think of it as area. Alright, so maybe pause the video and see how could we cover this roof with this bit of felt. So we'll imagine now that you've paused there now. Alright, so we could lay it in horizontal strips. Alright, so we know that this diagonal measurement here, x, is the square root of 5. And if we just want to figure out what the square root of 5 is in terms of a whole number, it is equal to 2.2 and a bit of change. Alright, so you're going to need at least 3 lengths of that, because you're going to have an overlap if you're going to lay it that way. If you laid it on this way, alright, 1, 2, 3, 4, and that's edge to edge, so you're going to need 5 lengths, alright, of this here. So you're still going to, whatever way you cut this, you're still going to need 3 rolls. Alright, you're going to need 3 rolls of that felt, so it is 40 euros by 3 is equal to, so what's that, 120 euro, and that's basically the whole cost. So it's going to cost you 156 euros. Now, pause it there. Alright, so just one thing on this question, that's why I was going to pause it or not pause it. I just went and checked the back of the book there, and it's actually 116 euros is what they're coming up with. The reason being, right, these are people that have decided and they've wrote a maths book, but they haven't actually thought about maybe the principles of the question. If you were to do this practically in real life with these materials here, there is no way that you could refelt that without having an overlap, without doing it correctly, with just 2 rows. So they have taken the 18 euros, right? They're just simply working on area. So the area for 2 cans was 12 meters squared, whereas the roof area is 4.9 or 8.9, should I say. So they've said, well, I need 2 cans. They've looked at the area of the felt. So if I lay out the felt, it takes the shape of a rectangle, 1 meter by 5 meter. So the area of one sheet or one roll of felt is 5 meters squared. So 2 rolls gets us to 8.9. But if we actually want to realistically do this, we need 3 rolls. Alright, so it's going to cost, to get the job, if you want to keep the rain out, 156 euros. If you want to follow the guys writing in the maths book, it's 116 based on simple area, right? But fortunately they don't have a clue how to weatherproof a roof. Alright, so I have the lights on now there, it's just getting a bit dark outside, so I've skipped on right onto the test yourself exercises. I don't think there's really anything to most of those. The last one there, question 15, is to do with your TV, is the one that we're going to just kind of, there's a little bit of thinking to do with that. I presume looking at what you've handed in, no one actually got it, so we'll just talk through it now. If there's any ones that haven't done, just drop me a message in the Google Classroom and we'll get to it. Alright, so Miriam's thinking of buying a new TV, right? So she's looking for a 40-inch TV, and 40 inches, basically we're measuring on the diagonals. Alright, so your TVs are measured on the diagonal. She's looking for a 40-inch screen, and she's looking, first of all, the aspect ratio, basically the sizes of the height to the width is given either 16:9 or 4:3 is a different ratio. Alright, so she's looking for a 40-inch. We're told, first of all, to convert 40 inches from inches to centimetres. And we're told that 1 inch, alright, so 1 inch is equal to 2.54 centimetres. Alright, we're asked, first of all, to convert 40 inches. Okay, so 1 inch is this. We want, I don't know, 40 inches. So 40 is equal to this figure multiplied by 40. So 2.54 by 40, and we're going to get 101.6 centimetres. Alright, and that's that. So that's part 1. Alright, part 2, find the width and height of the screen in centimetres and give your answer correct to the nearest centimetre. Right. Forgetting about a TV, we'll just take half of the TV, cut it down the diagonal, and we're going to end up with a right angled triangle. So here now is a right angled triangle. Now, this lady wants a 40-inch TV, so this here is 40 inches, or we've now found to be 101.6 centimetres. We know the aspect ratio of the TV, it's 9:16. Alright, we don't know, it's not 9 centimetres is to 16 centimetres, it's 9 parts is to 16 parts, but we don't know what a part is, so we're just going to call that unknown part x. Alright, so 9x and 16x. Alright, from that then, that should be enough information for you to go ahead and solve and do part 2, which this is, and then on to part 3. So if you couldn't figure it out before, pause the video, go off, do it yourself, come back, see do you get the correct answer that you've got here. Assuming that you've that done now, so you've paused, worked and come back, alright, because none of you got it, so you do need to go back and pause and do and work on from this. Right, I basically want to find out what's the value of x. Alright, I have a right angle triangle, so I'm going to work with Pythagoras. 101 is my hypotenuse, and I'm going to square that because the length of the hypotenuse squared is equal to the sum of the other two sides to be squared. So it is 16x, alright, to be squared plus 9x to be squared. So I'm going to leave that as that for the time being. And over here, this is so I'm going to get 337x squared. So basically numbers to be squared: 16 by 16, x by x, 9 by 9, x by x. So I'm getting over here 81x squared, and this is obviously the difference in this. What is my x squared? Well, I don't care what 337 of them are, I want to know what a single one is. So if I divide both sides by the 337, I'll get what x squared is. So I'm just going to leave this in as this, and I'm going to put it into the calculator at the end rather than having a big number out here. So 101.6 to be squared. Divide that by the 337. And that will be equal to your x squared. Now I want to find what x is. Alright, so I'm going to have to get the square root of this. Alright, I'll put in here, I'll go up there. Alright, so putting all of that into your calculator, and we'll come up, do it up here. So then x I'm finding out here is going to be, so the square root of 101.6 squared all over 337. Alright, 5.5 centimeters. So that is what one part is. Now remember, we have 9 parts and we have 16 parts. So we want to find the height and the width. So I'm going to take and multiply this by 9. And I'm also going to multiply it by 16. Alright, so 5.5 by 9. And it was asked us to round up to the nearest centimeters, and 0.5 is what end up as 50 centimeters. And we're going to get 16 by the 5.5, and that is exactly 88 centimeters. So height and width of the TV with an aspect ratio of 9:16. Alright, that's part 2 done. Okay, so all you had to figure out was, I don't know the actual values of the measurements here. I know that it's 9:16, but 9:16 what? It's 9:16 parts. So if you had 9 centimeters by 16 centimeters, or if we leave it in inches, then you would have got a diagonal of something like 18 point whatever. So you would have got a diagonal length of 18, okay, but you just want an 18-inch telly, she wants a 40-inch telly. So we need to expand this out. So the 9 and the 16 stays in terms of a ratio between each other. Alright, so it's 9 parts high, it's to 16 parts wide. You just need to figure out, well, 9 parts of what and 16 parts of what. So basically, we want to find what the value of x is. So you have to say that it was 16x and 9x. Then go to your Pythagoras, square it, find the value of that part x to satisfy, as a Mary, and having her 40-inch wide TV. So we found that the height of it is 50, the width of it is 88 centimeters. Okay, that's for part 1 and 2, and part 3 then we've got a different ratio, and we're asked to work out which of the 2 TVs has the greatest screen area. Alright, so again we should redo this now. So 3 parts is to 4 parts, but again we're looking at a right angle triangle. So 3 parts x, 4 parts x, and this is your 40-inch, which is in centimeters, 101.6 centimeters. So again, 101 squared. So I'm going to do this a little bit quicker than what we've done before. So 101.6 squared is equal to, adding all of that together, we're going to get 25x squared. So divide this by 25, divide that by 25. So the square root of 101.6 to be squared all over 25 is equal to x. Okay, so that's what x is this time. So now I want to get what 3 times and 4 times it is. So 3x is equal to 4x is equal to closest centimeter, 61 centimeters, and 20 point. Okay, so this TV, instead of having a height of 50, it has a height of 61 and a width of 81 compared to a width of 88. Alright, so we want to find out basically the area, okay, of each one. And I'm just going to, because we've got a small board, a lot of black marker, I'm just going to go change it to red. So work out the area of this top 16:9 aspect ratio TV. Alright, length by width 50 by 88. I'm going to get the area here is equal to 4,400 centimeters squared. The area of this TV here is the 61 by 81. And that's going to give me a larger number, so 49.41 centimeters squared. So to finish up on that, which TV has the greatest area? Well, it is the aspect ratio of 3:4. Alright, so as I said, I only done question 15 there to test yourselves. If you need any more help or whatever, shout a question at me. I might just type out how to do the solution rather than make another video. But like, use your head. You know, these are all based on right angle triangles. You need to then pull out the right angle triangle, draw it out. Right, we had the TV, but I drew a triangle. Okay, John, the both question there, make it into right angle triangles. Any of these questions, make your right angle triangle. Work out the sides, angles, whatever you need. Alright, enjoy the weekend. We'll see you.